Next is Pert. Pert means project evaluation and review technique. It is used to schedule projects with uncertain activity duration. The duration of an activity is estimated as a range of time values rather than being a single value. To incorporate uncertainty in the scheduling process, the critical path method is applied first. Then the results are analyzed using probabilistic perspective. So here we are using probabilistic perspective. If you are considering CPM, that is deterministic approach. Clear? What is probabilistic approach? I already explained about the Pert. What's the basic concept, how the durations are calculated in the previous class. Okay. So Pert, using expected activity duration and critical path method, the critical path of activity can be identified. This critical path is then used to analyze the duration of the project, incorporating the uncertainty of the activity duration along the critical path. The expected project duration is equal to the sum of the expected duration of the activities along the critical path. Assuming that activity durations are independent random variables, the variance or variation in the duration of this critical path is calculated as a sum of the variance along the critical path, which is the mean and variance of the identified critical path. The distribution of activity duration can also be computed. So I already explained these things. So we have time estimates. Okay, the Pert analysis, we are having time estimates. We are using optimistic duration, most likely time, and pessimistic duration. In some books, you can refer like optimistic time, most likely time, and pessimistic time. So optimistic time is the minimum time required for an activity if exceptional good luck is experienced with all favorable conditions. Most likely time, the time required for the activity under normal condition. Pessimistic time, the maximum time required if unusual bad luck is experienced with highly unfavorable condition. Then we find mean of a particular time, and then we have to find the variance. Okay, so mean and variance are derived by assuming that the activity duration follow a probabilistic beta distribution under a restrictive condition. The probability density function of beta distribution for a random variable x is given by f of x. F of x is equal to k into x minus a whole power alpha into x minus b a whole power beta, where a is less than or equal to x, less than or is equal to b, and alpha comma beta are greater than minus 1. So k is a constant which can be expressed in terms of alpha and beta. So beta distribution, when alpha is equal to 1 and beta is equal to 1, the spread will be more. You can see the Bell distribution graph, the spread is very high, and when alpha is equal to 2 and beta is equal to 2, the distribution from the mean, the distribution is getting reduced. Okay, and when alpha is equal to 4 and beta is equal to 2, the shape is a little bit not symmetric from one side. Okay, so based upon value, it will change. So expected mean time, we know that estimated time TE is equal to optimistic time plus 4 times most likely time plus pessimistic time, the whole divided by 6. Okay, so we have to find the TE based upon this formula. Then standard deviation is equal to standard deviation sigma is equal to pessimistic time minus optimistic time divided by 6, and variation V is equal to sigma square. Okay. How to find the expected project duration? The project duration is determined by summing up the expected mean time of activity along the critical path. Variance of the project duration is obtained as a sum of the individual variance of these critical path activities. Applying probabilistic approach. Okay. So once the expected mean time for a project duration, expected mean time, here they are mentioning it as Tx, and its standard deviation, that is sigma for particular time x, are determined. It is possible to calculate the probability of meeting specific project duration. Okay, so Z is equal to Ts minus Tx divided by sigma x. So the normal probability table are used to determine the probability corresponding to the value of Z. Okay, the Z value ആണ് നമ്മൾ എടുക്കുന്നത്. Let go through the example. So activity A, that is site clearance. Activity B, removal of tree. Activity C, general excavation. Activity D, grading general area. Activity E, excavation for trenches. Activity F, planning form out and reinforcement for concrete. And G is installing sewer lines. H is installing other utilities, and I is pouring concrete. And predecessors of for corresponding activities are given, and durations is also given. First we can draw network diagram. So we can use here precedence network diagram. Okay, so this particular problem will give you a little bit confusion. Why? Because crossing of activities will happen. So let me see how can we draw it. For example, activity A is begin first. Okay, so there is no predecessor for activity A. So activity A. Okay, then B, C, and D, predecessor activities A. So it means from A we can draw B, C, and D. Okay, next is E, activity E. Activity E have two predecessors, that is B and C. B and C. Okay. Next, activity F. Activity F also B and C. Okay. So for example, if I am considering like this, if I am having F here, from C I can draw very easily, but from B when I draw, this will cross this particular line. Okay. So we have to draw like B. Okay. There is some cross. We can just by while drawing itself, we can clearly mention by providing a small hump that this particular arrow is from B to F. Okay. Okay. Next, activity G. Activity G, predecessor is D and E. D and E. Activity G. Activity G. D and E. Then activity H. For activity H also D and E. So if I mention H here, It is very easy for me to draw from E to H, but when I connect D and H, there is an arrow between here, so I have to provide a hump and I have to mention like this. Okay. Then for I, F, G and H. G, H and F. Okay. So this is the way the diagram will come. So we have to rearrange it once again and make it visible very clearly. Okay. So this is the uh, same diagram, uh, but when we make it in PPT, it is a little bit difficult to draw the junctions by providing a small hump like this. Okay, so that's why I give you separately how to draw this particular diagram. Okay, the same diagram only. Okay, so this is precedence diagram method. First, we have to mention activity along with the duration, then earliest starting time, earliest finishing time, latest starting time, latest finishing time. So when you complete, when you put the duration, and you have to go for forward pass, then go for backward pass, then find float, okay, and from there you know how to calculate the critical path. In this particular activity, activity A, C, F, and I is the critical path. Clear? So based upon the given data, we are drawn this particular method. So from the critical path, we are choosing the critical path alone in order to find the expected duration. Okay, so we are having A4, C8, F12, and I6 is the duration. So we are taking A, C, F, and I, and the most likely time we are providing with the given duration. Okay, so based upon the experience for activity A, what will be the optimistic time? So based upon the experience provided as 3, and the pessimistic time is 5. So similarly, each activity, the optimistic values are given. Okay, then from this we can find the expected time, that is TE. TE is equal to uh, optimistic time plus 4 times most likely time plus pessimistic time divided by 6. Clear? Okay, then we need to find variance. Okay, in order to find variance, we need to know sigma. Sigma is equal to P minus, that means pessimistic time minus optimistic time divided by 6. Clear? So find sigma individually and find variance. Clear? So you will get this variance. Okay, so expected project duration is, we know that the total duration is 30. We obtained here as 30. Okay, so the expected project duration, that is 4 plus 8 plus 12 plus 6 is equal to 30, and the sum of variance for the critical activities are this. You have to sum up all these variance. Okay, do not find a standard deviation directly for each and individual thing. Instead of that, you can find this note. The standard deviation do not add to give a total standard deviation. We have to first add their squares, that is the variance, and then take the square root to find the total standard deviation. We need to find the standard deviation at the last. So we, from the variance, okay, after summing up, you can get this variance, then you can square root it. Okay, variance is equal to sigma square. we need to find this sigma for the entire work. So finally we have to find sigma is equal to square root of the variance. Okay, so the variance, sorry, the standard deviation obtained is 1.2. So the question is, we need to find the z value for the normal probability. Okay, so we know that project duration, the mean value is 30 duration. Okay, the question is, for example, the probability of project completion within 35 days. Okay, so the formula is z is equal to ts minus tx divided by sigma x, that is 35 minus 30 divided by 1.2, that is 4.167 will come. When we go for the normal distribution table for z value, it will come maximum of 3.99 only. Since you obtained here, we obtained it 4, surely 100% will be there. So we can go through the table. So this is a standard normal distribution table for z value. The z value, so you can see 3.9 in the x-axis, and in the y-axis 0.09. It means 3.99 is the maximum, and you can see 0.999997 percentage. It means 99.9997 percentage it will come. But we obtained z value as 4, greater than 4. So sure, is it greater than 4? The probability of completion of this particular project in 35 days is 100%. So is it is a tabulated value of standard normal distribution, and corresponding probability can be obtained from standard normal distribution table. Hence the probability of completing the project is 35 as 100%. Okay, so what will happen if I want to complete, can I complete, what is the probability of completing this particular activity in 29 days? 29 days, we can calculate like 29 minus 30 divided by 1.2. How much it is? You will get minus 0.83. Okay, so we have to find the value from the table, minus value. Okay, minus value okay, minus 0.3, minus 0.8 is here, minus 0.83, minus 0.83. You can get a 20 point, that is 0.20327. So that is, if I try to complete this particular activity in 29 days, the value obtained is minus 0.83. For this particular minus 0.83, the z value is 20. That is, if it make it in percentage, it will give you 20.3 2% chance of completion. Got it? You can try this particular work by yourself. The R&D project has a list of tasks to be performed, whose time estimates are given as follow. That is, activity is given by a notation I and J, okay, and activities are given. Optimistic time is given, most likely time is given, pessimistic time is given. So you can draw a project network and the critical path. Find the probability that project is completed in 19 days. First, you have to find the completion probability duration is 19 days. If the probability is less than 20%, then find the probability of completing it in 24 days. So you have two tasks. Okay. So one task is you have to find the probability of completing it in 19 days. And if the probability is less than 20%, find the probability of completing it in 24 days. Okay. So do it by yourself, and if you found any difficulties, kindly ask me.